All right. I guess I'm just going to go ahead and start. All right, all right. Happy, happy Saturday. Yeah, the week just kind of snuck up on me. I thought it was still Thursday or something. But it's Saturday today. So, a morning stream. Yeah, yesterday for those who pay attention to the titles, it's called Programming in the Rain because right now it's raining outside and I don't know how long the internet will last. So it must be where we are, but every time it rains really hard, the internet drops, and if they're doing construction nearby, it starts raining, that effectively the internet just completely cuts out, and then I don't have access to it for hours, which happened yesterday, which is very annoying. I mean, I still have access via, satellite, so my phone works perfectly fine. But the landline, boom, gone. That kind of sucks. Either way, let's program. I've been thinking about this a bit, trying to think about how I'm going to program this here, and I think I figured out quite a bit. The main thing is that we're going to start building out our dict file, these config files, while we are compiling things. And we're going to take advantage of a lot of additional information, for instance, like image shape. This will become a lot more important when it comes to generating stuff. In fact, odds are I might move this over into the frame config as well. So let's see here. You can kind of start seeing some of that right here where I'm starting to build it out. Actually, I should put in my, okay. Oh. All right, next time. Next time I'm going to put in handcrafted code into the title, because that's kind of what we're doing. We're not really using AI. We're trying to think things through to help, stretch the programming muscles. I would like to say that at some point actually, this is something worth... Maybe I can actually turn this into a clip. So let me go ahead and load up GIMP so I can show off what I'm trying to talk about. Yeah, I'm gonna try and make a clippy short spot. Clippy clip. Oh, it's kind of fun when the program does this. Oh, where are you? Oh yeah, it already moved. Oh, it's going to make the white moment. It's going to make the background very white if I... There we go. Okay. There we go. Perfect. All right. So... And I'm going to... I think this is good. Yeah, this is perfect. Okay. This is perfect. Okay. So... Yes. I have a strong feeling that because the fact that... Oh, that is so big. Oh my. Alright, let's... Why are you so big? There we go. Okay. Alright, yeah. So I have a strong suspicion that what's going to happen, because LLMs, they have improved dramatically to the point where... Effectively, if you're going to be going into any form of field, you're going to be using an LLM. Either through, building tests, so testing, or through simple code generation. I know some people are even using it for beta testing, so building beta style projects. I'll put features here. So yeah, LLMs have pretty much, they have reshaped how the market runs. However, if you notice, I noticed a trend going on. It's a very interesting trend, in a sense that all of the people who talk about how great LLMs are, they're these really, really strong programmers. You have your people like the Primogens. You have the Caseys. You have the JTs. Actually, I don't think it is Casey, but you have your JTs. These are the people who are in the stand-up on Primogen's channel. But then also, if you just look around in the industry, you'll find like Linus, you know, the Linux guy. He also has been going out there and saying how important this tool is involved in production and developing code. And if you notice, the main thing is all of these people are expert programmers. They're the experts. So odds are what's probably going to be happening is as LLMs slowly become adopted more, it will kind of be the way of the calculator. So what do I mean by that? Well, think about it. When you're a kid well, I don't know about nowadays, but back then when I was a kid, from the ages of 5 all the way to 10, our little powerful calculator with all of its buttons near your screen, in this case had a nice little thick button here, this was banned. We could not use it from ages 5 to 10. Everything had to be handwritten. We had to do 5 plus 5 equals, 10, or 2 plus 2 equals fish. We had to learn these things by hand, and we had to go through the times tables over and over and over because we needed to understand these fundamentals. We needed to understand how this would work so that by the point in the future when we started using the calculator, we knew what was going on. And I have a strong feeling that the same thing is going to happen with LLMs, because this is a powerful tool, especially for coding. So things like coding and particle animation, a lot of different areas, they're being enhanced by LLMs. But if you don't understand the fundamentals, then you're going to get quickly lost, and this tool it can't support your project will not be able to progress if you don't understand the fundamentals. So what most likely is going to start happening is you're going to have, if I had to guess, especially when it comes to a university environment, is we're going to start having LLM courses. And this will be, man, why do I always, anyway, these LLM courses, what will happen is that these will be there to teach you how to use LLMs along with, they'll call them fundamentals. So fundamentals of coding, or, fundamentals of, I guess, art, something along those lines. And this fundamentals class will become extremely important, like super, super important. Because if you do not understand the fundamentals, then you will not understand the tool. And if you don't understand the tool, then effectively you will be lost in anything that's more complicated than a basic function. So yeah, I think that this is how things are going to progress, especially when it comes to these things, because yeah, without this, you're not going to be able to make it to the same level of the Linuses or the Primogens or the JTs. So we'll have to see if what I think is going to be accurate. I feel like it's going to be the way of the calculator. Instead of calculator, though, it's our LLM. It's our neural network models. So you're not allowed to use it during the first 5 to 10 years of your learning, your education. And then suddenly, you have full access to it at all times. We'll see. But yeah, that's what I predict. Anyway, let's get to actual programming. And I shall crop that and put it into a video later. Part of the reason why this is part of the reason why I'm still handcrafting my code here. I'm pretty sure that this system that I'm trying to develop, if I use the latest models, then it would probably be spat out and completely done in no time. But I need to work the muscle of my brain so that I can, think more logically as step by step on why I should do a thing a certain way. For instance, right now, I'm trying to think of a good way to speed things up. And that's actually kind of the point here, is because if you do not have a solid foundation, then when something shows up in the code, you won't know if it's good or not. A perfect example that I can think of is when I was trying to... let's see here. I have a perfect example right in my code, which kind of shows the line between the line that I'm trying to talk about. Let's see here. Where are you? Let's head over to, not our generator. We are looking for, here it is, image manipulation. Aha, okay. Let's go ahead and shrink these bits. There we go. Get a nice big window open. Perfect. Okay then. So if you look here, this is the get tracking. This is before and this is after. We're going down. Here it is right here in my overlay. So this is my function right here. The purpose of this function is to overlay 2 images. Because I'm working with RGB, red, green, blue, 3 channels, that's what makes up the color image. What I end up doing is I end up running it through a for loop. And from here, I will go through each layer, process it, and then output the result. Now, because of this, it's a for loop, which means I've induced a certain time, it's no longer... is a log of n pretty much, or was it n log of n? I don't remember which one it is exactly, but because there's a for loop, I've actually induced a certain amount of delay in how long this program can function. And when I throw this into the LLM, when I look online, you quickly find that a lot of people recommend you do it this way. Make a for loop, go through the 3 colors, and output it. You're done. But after when I was trying to do optimizations and figure things out, I quickly realized, why am I doing that? This is a bloody matrix. Can't I just do generic matrix calculations? Take the 1 layer and then transpose it onto the other 3 layers, because all I'm doing is I'm doing calculation via an alpha channel. It's the color multiplied the alpha channel. You can see it right here. It's the color multiplied by the alpha channel. This way it will allow me to make the overlay a lot smoother and less look a cutout. So I do that, and then I do the same thing for the other image here. So here's the image color times the alpha channel, and then the inverse of the other, or times the 1 minus the other alpha channel. And this way it's to prevent over, so they're not competing. One of them has to be a much dimmer than the other one. And since we're overlaying picture 2 onto 1, then we need to multiply by the inverse of the alpha, to do that. So here we go. You can see here very basic. I'm like, why not just do this all in one line? So here you can see the modification. If you look right here, I take all 3 layers with the colors. I multiply it all by alpha 2 because of the fact that the dimensions are very obvious and we're transposing them over onto one another. I don't have to cycle through them. I can just do this multiplication. And then I can do the exact same thing again here. So effectively, what I've done was I've removed my for loop in favor of just one full calculation. So look at that. Instant speed boost. Nice. But you wouldn't know this if you didn't understand the fundamentals. Because all of the LLMs will be producing this code because this is how it was trained to do it. Maybe in the future. Maybe when enough people start doing calculations like this, that the LLM will start producing this as an output. But it still doesn't change the fact that you need to know the fundamentals. So, yeah, maybe we'll have to start... Oh yeah, I just got a warning. Oh yeah. But yeah, maybe we'll have to... There might be a field in there. Actually, I should probably start doing that. I'll start making videos called Programming Fundamentals. Put an emphasis on, if you know the fundamentals, then you can fly with an LLM. Because that's technically what it is. That's the same thing with math. If you know the fundamentals of math, like 2 plus 2 is 4, and 1 plus 1 is 2, and things that most people think are brain dead, 8 times 7 is 56. When you learn these things, then you can, when you get into a lot more complicated steps, then you can quickly start running through. Let's see here. Where are you? I'm heading over. I should probably tie. Let's see here. See, Hong Kong Observatory. This right here is the weather system for Hong Kong. It tells us everything we need to know. If you notice, all of Hong Kong, so here you go, Hong Kong Observatory, all of Hong Kong is currently in a thunderstorm. What this means is that we're going to have thunderstorms. Actually, let's see here. This was issued 8:55. It's going to be valid till 11. There's going to be isolated thunderstorms. At least it's not going to be raining too much, so that's a good sign. But yeah, that pretty much means if stream gets cut out, sorry about that, I can't really stop it. And no matter how much I wish I could. Let's see here. We have a nice big rain band right here. Okay, let's not get distracted. Let's the main thing is the weather doesn't look like it'll affect us too much. So I can at least program for about an hour and a bit. So let's do that. All right then. So the first things first. What we need to do is we need to define a couple different features. So if you remember yesterday, I ended up programming in an auto crop. Here we go, right here. Here's crop from, here's auto cropped. And the idea is that what it's going to do is it's going to find the min and the max and where we need to locate and then crop that. And then it'll give me the crop space. Now, I've been spending a lot of time thinking, like, how am I going to store this information, especially with the images? There's a lot of information that I want to keep track of, especially when it comes to speeding this up. One way I thought about doing it was kind of building putting this all in a dictionary. We're building up a frame dict, and that's going to be there. But then the next thing I thought of is an issue, and that is the fact that I've been adding in layer modes. I have variant now. I have dynamic, variant, and static. What that means, if we look over here at our data structure, is that we're no longer going to have the talking animation here. I'm still going to have this here, the layer config, but what this is going to entail is mostly the frame rate and the modifiers. Well, it's going to, okay. It's going to still have this information, but what it's going to do instead is tell us how the series of images is going to be. This is going to be a bit converted. Instead of it being its own layer config, what's going to happen is this is going to be put right here. This will be named talk config. And then from that, what it'll then do is it will give us the... so here we'll have the image shape, so we'll know... I don't think it needs image shape, so we can get rid of that. Background color is something that isn't... I think background color is something that probably actually doesn't need to be here either. Because we're going to have that built into the framer, because we're going to be auto-generating a couple images so that we'll be able, keep this in memory. So yeah, background image won't be needed, but frame rate will be needed, because this will be how often we update the how often we send stuff to the frame buffer. If we set it to like 12 frames per second and our frame buffer is running at what, if our frame buffer is running at 24 and we have a frame rate of 12, then we're going to have to start doubling up the frames, in order to keep things running smoothly. So we'll need frame rate, we'll need modifiers, and then this will be, because this is now going to be the sequences, so this right here will be known as, let's see here, this will be known as the sequence. And then from here, yeah, this is where things get interesting. How do we generate the sequence? Because part of me feels like, oh, yeah, this is where we're trying to figure things out. Well, let's look at the data structure and how I'm organizing it. Let me hop back over to GIMP real quick so that we can think about this. And of course, I write on my background image. All right then. Okay, perfect. All right, nice. All right, so let's see here. We have our frames. So these are our animation frames right here. Oh, okay. Yeah, if we don't understand how our data is structured, it'd be a bit difficult to figure out how we're going to store the data. So the idea is that this frame here is made up of individual tiny frames, like so. So this would be the body, tail, VR, and then mouth. And then this would be, for instance, 1, 2, we'll just have 4 frames right now. 1, 2, 3, 4. Now, because the tail is changing, this one has tail right here. So it's always, this is part of the animation. The body can be different individual pieces. So body 1, body 2, body 3, like so. Ew. Yeah, this is two competing ideas that I just thought of, but because the mouth here, the idea is that there's also going to be different mouth parts, because the body might move. For instance, if our body is standing, and then it decides to, stand on one leg, then the face is going to be in a different location. Because of that, when I'm going to have him talking, the face is going to have, 2 frames here, and then 2 frames here, like so. This is right here is what I'm calling dynamic. Now, because of the fact that the body can have things like a pair of pants, or it can have a t-shirt, kind of like this, this is what I'm calling variant. This is what I can control via, the keys, and this doesn't need to be stored in memory. But dynamic, because these are the various different ways, the frames in which the mouth can be, then this means that it can be a variety of different, at different points. What it does is it allows me to kind of tie tie these to the positions of the body, or tie the different mouths to positions, so that when my character moves, as in this character transitions between these 2 poses, I can still have him talking. And I can still theoretically have the tail flicking as well, because that's kind of the thing I want, is the tail to move, to transition this movement while my character happens to be saying things while he's wearing a t-shirt. However, because I have set up, here's 4 different frames, because this is under the assumption that there would be 4 different body points or something. And then the mouth, as I said, the mouth would have, variants, like so. Oh, maybe the tail would be classified as a variant as well. That means, theoretically, everything will be stored in a single frame. Long gone will be my long animation sequences. Because if you look at my the way that we have things sorted or stored here, you can see here are all of the 12 frames. Here we go, all 12. And if you go into 2, you'll see that the main things that are changing are the eyes, the tail, and the VR. And that's because the character is blinking and the tail is flicking. So, but if I did, let's see here. If I did let's go over to, was I doing the tests in Curious? It might have been in anger and talking frame, okay. I don't know where it's located. Well, let's just go ahead and start chopping up one of these. Let's just go ahead and start chopping up one of these. So the idea then is that, because here you can see these are the different dynamic poses. Or I should say the different... Oh man, these are the different poses that can be programmed in. Man. So here are the different body poses. Oh, I know. And set. Yeah, we can probably do it here. Because the mouth is going to be changing here. There's our accessories. Always this area. This is where we always get trying to think about how things would be set up. I think maybe the tail should be considered maybe the tail should be considered dynamic as well. And we just kind of forego this particular... I don't know. Trying to implement in the ability to talk. Well, how about this? We can we'll sit this back to think about it a bit more. But for now, let's go ahead and just start working on the optimization stuff. We can think about it more as we progress through. Maybe we'll have an epiphany, a lightning strike, and we'll figure out, oh, this is exactly how we want to do it. This is the perfect way. Let's do it this way. So yeah, that's what we can... That will be our idea. So let's see here. I'm busy looking. So let's see. I think maybe, yeah, we can do it here. Frame config, we can probably have something called positions. Okay, alright. I feel like I should probably combine this. So I have, well, okay, yeah, that's a good idea. I was thinking about combining these in like, we'll have them called layers, and then have arms, and then I'll have all the individual pieces. By doing it this way, it allows me to go, oh, what's about the information I need to know about the arms? I can pull arms out of the dictionary, and then it can go. I can get all of this information about it. However, I think in this particular case, it's probably better to keep them separated. What we'll do is we'll put position right here. And then it'll pretty much be this same setup right here. However, this will just simply be the tuples. So I remember this all ends up becoming a list. JSON does not have the ability to import tuples, so. But yeah, these will all be lists. And then from here, we can then have the information. It makes sense when these are all static, though, because the parts are going to be changing around. I thought about this yesterday. Again, this makes sense when we're not when variant, because here, if we look here, for instance, right here, if you look, the structure